Year-long efforts of fishermen and scientists on board the tuna vessel Queen Mary have provided a new avenue for exploring tuna-porpoise interaction. One crew's objective was to film her seining operations and porpoise safety techniques. A day begins early aboard a tuna seiner. Weather permitting, experienced crewmen look for signs of fish. Strong 20-power binoculars aid in the vigilant search from dawn to dusk. Tuna signs are subtle and easily overlooked. Porpoises. Rippling water called breezers. Even floating debris, always called logs, whatever the material. Watchful eyes scan the horizon for birds. The man-o-war, the boobies, the petrel, all suggest the presence of tuna. Porpoise are sighted. Moving closer, the seiner checks for fish. Tuna seining involves capturing both pure schools of tuna and tuna associated with marine mammals. One tuna species, the yellowfin, frequently travels with air-breathing porpoise. The captain climbs the mast for better visibility. From the crow's nest, he determines if the porpoise carry fish and directs operations accordingly. In anticipation of a possible set, the net is attached to the skiff. When the presence of fish is confirmed, the order is given to launch speedboats. The seinermen quickly respond. Initially, the boats remain close to the main vessel. When the herd is in range, the captain directs the boats into action by radio. The number 1 speedboat begins turning the leaders and, working with the other boats, herds the porpoise similar to handling cattle. Frequent high-speed turns and zigzags keep them together. Crewmen stand by and await the captain's orders. On his command, let her go, the quick-release pelican hook is stripped. Holding one end of the net, the large skiff slides into the seiner's wake, smoothly pulling webbing into the water. Turning against the direction of the seiner, the skiff holds the net's bow end, called the bow orza, stationary. The net is set carefully at the seiner's cruising speed. A radical change in direction could foul the cork or chain line, causing a net malfunction called a roll-up, which may interrupt operations. About half of the net is now deployed. The vessel continues a smooth port turn. Webbing, with its corks, chains, and rings, falls evenly into place. As the seiner moves toward the skiff, the stern end of the net, called the stern orza, leaves the deck, its tow line feeding out from the main winch. Completing the circle, the seiner meets the net skiff, which is carrying both the bow orza line and a purse cable. The seiner drops a pickup line. The other lines will be attached to it and hoisted aboard the seiner. The bow orza will be connected to a fitting on the workdeck rail, where it will remain for the rest of the set. The first cable is pulled through a block and connected to the main winch. In less than 10 minutes, the tuna porpoise school has been encircled. The net skiff, now free of orza cables and lines, moves to the starboard side of the seiner to pick up a heavy rope connected to a towing bridle. It motors out to pull against the main vessel to keep it from drifting into the net. Webbing tangled beneath the seiner could cause net retrieval difficulties or major net damage. Circling speedboats guard the tow line area, since there is no webbing from the main vessel to the stern orza. The boat's actions prevent porpoise and tuna from leaving the net. If porpoise escape, the fish will follow. After the bow ortha is secured, the main winch pulls the tow line aboard, returning the stern ortha to the seiner. With winch drums rolling in purse cable at carefully controlled speeds, the ongoing pursing process draws the bottom of the net together, like a drawstring closing a woman's purse. The stern ortha is tied at the seiner's port side, closing the tow line escape area. At the bow, crewmen pull and tie off 3 bunch lines. A speedboat, working as a court tender, assists by transferring each line. Pulling bow bunches reduces the net's perimeter and increases flotation to support the fish catch. Tons of tuna forced against the net can exert tremendous stress. Since bow bends can create entrapment places for porpoise and pose net retrieval difficulties, the captain is on the lookout for webbing drifting around the bow. A speedboat pulling directly on the cork line or towing on a single bunch line can easily resolve the problem. Speedboats are critical tools for porpoise safety. A single boat rigged for towing can correct bow bends, net folds, or canopies. Several boats towing on strategic bunch lines can control large areas of webbing or the entire net. Proper speedboat technique is imperative when attaching to the net. Approaching bow first keeps the propeller away from the net. A 10-fathom line connected to a floating ring on the towing bridle runs from the stern to the bow. It is coiled for over-the-bow use. The driver lies on the bow, attaching the tow line to 2 adjacent bunch line ends. A snap hook allows quick hookup. Backing up, then carefully turning, the driver avoids fouling the tow line or net with the speedboat's propeller. Winds, currents, or gear malfunctions may cause net collapse. At the first sign of problems, coordinated speedboat towing can hold the net open, an important factor for porpoise safety. If forced against the net, porpoise may become entrapped or entangled, preventing them from surfacing for air. Quick hookup and pulling by speedboats is essential. It is nearly impossible to reopen a collapsed net, but timely speedboat action can prevent it from closing further. For ease in locating towing points around the net, brightly colored corks mark the 3 ends of adjacent bunch lines. Pursing continues as the main winch hauls in cables. Connected by a heavy line passing through the power block, the stern ortha is raised to the port rail and tied off. Beneath the water surface, the purse cable is under tremendous stress, bunching rings and netting as it pulls them toward the seiner. Rings up marks the end of pursing. The net is closed and its contents captured. Cable clamps are immediately secured to the purse line. Hoisted into position, purse rings quickly slide down the ring stripper, clanking into place. Separated at a split link, the purse cable is pulled free from the rings, and, once clear, net roll begins. Webbing, corks, chains, and rings roll over the power block and cascade down 40 to 50 feet to the deck. At the console, the navigator carefully controls net roll and power block position. Cork line is twisted into position and neatly stacked on the starboard side of the net pile. A circling speedboat keeps porpoise away from webbing being rolled aboard. Rings and chains are arranged in order along the ring rail, allowing threading of the purse cable for the next step. Speedboats tow bunch lines at key locations around the net's perimeter to counteract the subsurface current threatening net collapse. Free swimming space is created inside the net, safeguarding against porpoise entrapment. This experience-tested method can keep the net open for hours. Porpoise congregate near the net center, swimming leisurely around one another. Their social behavior is most evident underwater. While some surface for air, others remain calmly below in groups. The number of porpoise, environmental conditions, and the amount of net in the water dictate how many speedboats should be used and where they should tow the net if collapse is imminent. With a large herd of porpoise, 1,000 or more, And with most of the net in the water, 3 speedboats are required. Their correct towing points, looking across the net from the seiner, are at 10 o'clock, 1 o'clock, and 3 o'clock. Even during minor malfunctions, speedboats should be ready to hook up and tow immediately. Small problems often take time to correct, enough time for the net to collapse. Each speedboat unhooks in turn as net roll brings its towing point near the seiner. Bunch lines must be cleared as each speedboat detaches. Failure to do so may cause jamming at the power block. Net roll is a time-consuming chore, easily affected by wind and sea. The captain comes down the mast to prepare for backdown. When approximately 2/3 of the net is rolled aboard, a choker is used to tie down the net. Controls are set for backdown. The seiner is positioned so its net forms an elongated channel. A raft is launched for herding, observing, and releasing porpoise. It will be paddled along the backdown channel as a herding platform. Intentional splashing by the raftman will direct porpoise toward the end of the net. Using face mask and snorkel, he will check the location and number of porpoise beneath the surface. This is essential since porpoise exhibit sleeper behavior, resting on the bottom of the net, appearing lifeless. Given time, they will surface for air, making themselves available for rescue. More splashing will encourage porpoise to leave the net during backdown. A crewman enters the water. He mans his raft and moves toward the apex of the elongated net. It is imperative that men working from a raft be properly positioned. Lying crosswise increases maneuverability and ensures safety. The raft can be moved by pulling hand over hand along the cork line or by using a paddle. A tether line fastened to the cork prevents it from being backed out of the net. Porpoise usually mill around as a group near the center of the net, many of them rafting at the surface. For their protection, special small mesh webbing covers the entire backdown channel. Crewmen are nearby, prepared to rescue porpoise needing help. The raftman is ideally situated for hand release. With its main engines in reverse, the vessel begins backing down. This maneuver concentrates porpoise at the apex of the channel, where the porpoise safety panel and super apron have been installed. Constructed of fine mesh webbing, the safety panel protects porpoise from entangling their snouts and flippers as the net is pulled out from under them. During backdown, the super apron, a triangular extension of the safety panel, forms a ramp which funnels porpoise from the net. It functions like water pouring from a pitcher, resulting in efficient, safe porpoise release. For the super apron to work correctly, the backdown channel must be properly configured. A speedboat towing directly on the cork line can straighten the apex prior to backdown. A trial net set is imperative. The super apron is to work properly. Key apron points, marked with balloon floats, are aligned by adjusting bow bunches and the stern tie-down. Underwater observations are made to check for effective apron positioning. Working an apron requires special care, pulling an exact number of bow bunches, tying the net down at a precisely marked point, backing down in a smooth, continuous motion. Backdown must always be done with the seiner moving astern in a clockwise arc. At the apex of the channel, the cork line is pulled underwater, and water flow flushes porpoise from the net. This procedure allows porpoise release with little or no loss of tuna. By maintaining a proper turning radius, the seiner allows water action to develop a sufficiently wide and deep channel for efficient porpoise release. If the turning radius is too tight, water flow is diverted, causing a long, dangerous canopy to form, and corks are prevented from sinking at the apex. If the arc is too great, the entire channel will collapse before porpoise can be released. Speedboat towing may be necessary if backdown is interrupted by mechanical failure. 4 speedboats towing directly on the cork line, 2 on each side of the channel, can hold it open as long as necessary. During backdown, rescuers from a speedboat and a raft hand release porpoise in need of assistance. A speedboat with 2 crewmen is strategically stationed at the apex of the net, where the corks sink during backdown. A raft with 1 or 2 crewmen is within the net and may be tethered to one side of the channel. Being close to the surface and having the capability of looking into water, the raftman is ideally situated for hand-releasing porpoise. It is not uncommon for several crewmen to enter the water to release porpoise quickly by hand. Nevertheless, caution must be exercised whenever doing so to ensure personal safety. After backdown, any porpoise remaining in the net can be removed easily through coordinated teamwork between raft and speedboat rescuers. Although porpoise are free of the net, tuna remain cruising the length of the channel. Constant movement is necessary to ventilate their gills for oxygen. Confirming the absence of porpoise underwater, the raftman signals all clear. With the net to themselves, the yellowfin swim vigorously, churning the water surface. When the captain is confident that all porpoise have been released, the order is given to resume net rolls. Bow bunches are let out as webbing is rolled aboard. Sack up is close now. Net roll noticeably reduces the volume, concentrating tuna. Net roll stops as preparations are underway for sacking up. The skiff, no longer needed for towing, picks up a couple of crewmen and positions itself on the seiner's port side. The power block boom is moved to reposition the net. Crewmen now pull webbing aboard the seiner by hand, using a choker as necessary and bringing the catch to the surface. Securing corks to the skiff forms a sack of webbing running to the seiner. Fish are brought aboard by a large dip net called a brailer, which is lifted from the water by cables and guided by crewmen. Each brail, holding 1 to 2 tons, is dumped into a hopper for sorting. Tuna are funneled to the loading hatch and slide down chutes to storage wells below deck. As the sack empties, webbing is kept tight to concentrate fish for brailing. Yellowfin tuna prefer temperatures in the mid-70s and above. They are widespread in tropical waters of the world's oceans. These fish weigh approximately 45 pounds at 2 years and subsequently gain 50 to 100 pounds annually. Below deck, the chief engineer is responsible for the catch. He has prepared receiving wells with super-cooled circulating brine, which freezes tuna in minutes. After brailing, the remainder of the net is rolled through the power block. Finished with its work, the skiff moves behind the seiner, awaiting pickup as a crewman moves the double block pulley into position. Under the watchful supervision of the captain, pulley cables and skiff are carefully aligned, hooked up, and winched aboard. Grooves in the stern ramp guide the skiff to its resting place atop the net pile. It is held in place by a line to the pelican hook on the work deck, ready for another set. Once the set is complete, the vessel again gets underway, searching for fish. In preparation for the next set, the deck will be washed down, gears stowed, equipment repaired, boats refueled, and nets mended. The effective use of porpoise safety procedures greatly increases the efficiency of tuna seining operations. Speedboats are essential in controlling porpoise movement, alleviating net problems, and aiding with hand rescue. The rubber raft is an essential platform for herding, hand rescuing, and observing porpoise during backdown. Continuous backdown with a super apron and the assistance of rescuers can safely remove all porpoise from the net. We are indebted to the scores of biologists who have served as high seas observers and technicians. Their vital research in association with the invaluable contributions of fishermen have greatly advanced mortality reduction technology. These efforts have made decreased porpoise mortality a reality in the U.S. tuna purseine fishery.